What is up, everybody? Welcome to 7.3 Infinite Series. We're nearing the end of this math one. We're nearly the end of this math course, Integrated Math 3, and we are going to be exploring the infinite this time. As you know, the previous lesson we were exploring about series, just regular series, and we can see there's some pretty neat patterns and formulas that can be learned. For example, this formula that we've already learned. It's the first term multiplied by 1 minus the multiplier, the amount of terms divided by 1 minus the multiplier. Which, if the sum of all the terms of a of n is s of n, and the partial sum is s of n, right? So consider a of n is equal to 1/2 times n minus 1. And before we can find the sum of the infinite series, we have to be able to find partial sum to see where they converge to, right? Or diverge, and we'll talk about that later. But find s sub 1. What's s sub 1? Well, it's just a sub 1. So that's 1/2 1 minus 1. And what's 1/2 1 minus 1? It's 1/2 to the 0 power, which is 1. Next is s sub 3. Okay, we can start using this now since we have s sub 1. So that's 1 times 1 minus 1/2 to the 3rd power over 1 minus 1/2. And 1 minus 1/2 to the 3rd power is 1 minus 1/8, which is 7/8. And that's over 1/2. If you know regular skills, you can solve that. That is equal to 14 over 8, which is 7 over 4, or 1.75. S of 17, well, let's work it out. 1 times 1 minus 1/2 to the 17th power. I can't calculate 1/2 to the 17th power in my head, but I can tell you it's about 0.0000008 or something. So there's about 5 zeros. Let me just actually calculate it. 2 to the 17th power, 131072, and 1 divided by 131072 is, so it's about 1.99992, 1.99992. That's the answer, right? So you could see that 7 over 4, that's 1.75. That's 1, and that's 1.99992. If we find it in a pattern way, like a pattern, S1, S3, S5, S7, S9, we would be able to see that it comes closer to 2, which is what this is all about, right? So if you consider this formula of finding a series, so what happens as n approaches infinity? Now, this is a very abstract concept that you will need to learn for calculus, and I'm kind of introducing it to you because I might include an extra unit about limits, because once you're done with Integrated Math 3, you can basically do calculus. But there's a pre-calculus course for those of you who are insecure in math, which is totally okay, right? The pre-calculus prepares you for calculus. But I want you to get used to the ideas of change and continuity and approaching, right? Like, it's not that, but it's approaching to that. So what happens as n approaches infinity? So the notation that we use is the limit. The limit as n approaches infinity. We don't use, for example, in f of n, we write the limit as n approaches infinity of f of n. We don't write f of infinity because f of infinity is not a number. It can't be in a sequence if it's not a number. It can't be in a function if it's not a number. Infinity is not a number, it's a concept. So as n approaches infinity, as you give n's terms of 10,000, 100,000, million, billion, Googleplex, Graham's number, it will approach some value. And some of these values of k actually do approach a value. Some of these don't. So we will test it out, right? So let's say limit as n approaches infinity of a sub 1. So values of k is 7. So we have like 7 to the n minus 1. So that's just 1 multiplied by 1 minus 7 to the n over 1 minus 7. And as n approaches infinity, we get at the top, we have negative infinity over negative 6, which is just infinity. Right? Once we set it up to the limit as n approaches infinity, we can do these operations like as if infinity was a number. But without the limit, you cannot do the operation as if infinity was a number. So let's do negative 1/3. So 1 minus negative 1/3 the n power over 1 minus 1/3. As this approaches infinity, we have 1 minus negative 1/3 to the infinity over 1 minus 1/3. And let's say 1 is the first term. So as negative 1/3 approaches infinity, the whole thing actually approaches 0, because 1/3 times 1/3 is 1/9, and then 127, and then 181, and then 1 over 243. Right? You keep going, it'll become smaller and smaller until it reaches 0. So that will be 1 minus 0 over 2/3, which is actually pretty surprising because the result is 3/2. If your multiplier is negative 1/3 through the whole sequence, your result is 3/2. Even though there's a negative right there, your result is still 3/2. That's pretty surprising to know. What about 1/2? Well, let's do it. We've done it for the 1/2 before. We know what the answer is. Actually, the answer is actually 1 minus 1/2. Okay, the answer is actually 2. We set this to infinity, we'll have 1 over 2. 1 divided by 1/2, which is 2. What about value of 1? Well, if you think about it abstractly, I'm not going to put this in the equation, right? If we test for values of 1, we're going to get constantly adding an extra number every single time. We're going to constantly add 1. So 1 plus 1 plus 1 plus 1 plus 1 plus 1. So it'll approach infinity as well. This will also approach infinity. But if you do it the proper way, 1 minus 1 to the infinity power over 1 minus 1, you will get 0 divided by 0, which is very, it's not a fun thing to deal with. It's an indeterminate form. You will learn what those are in calculus. Okay, number 3. So these infinite geometric sequences, they can diverge to infinity. Diverging means going away from something, and converging means going to something, right? So they can diverge to infinity, they can diverge to negative infinity, or they can converge to a specific value, right? And the sum of the series with values of k that are between 1 and negative 1. So if we go back to this slide right here, this gave an undefined answer. This gave an infinity. This gave an actual answer. This gave an actual answer. Right? It gave 1/2. It gave 2. I mean, this didn't. This just gave 0 over 0. That's not an actual answer. It's in indeterminate form. So between 1 and negative 1, 1 and negative 1 exclusive. So 1 and negative 1 just doesn't work. We'll converge to a specific value determined by this formula. A sub 1 over 1 minus r. Right? Because anything you put here is going to be 0. Right? Anything you put here is going to be 0 as n approaches infinity. Right? So yeah, r has to be lower than 1, the absolute value. Right? So r of n approaches 0 and r is a fraction. And the sum with values of k less than 1, they will diverge. They will go crazy. It's the limit doesn't exist because you will be adding positive numbers that are way bigger and then negative numbers that are way bigger. So it'll keep going up and down and up and down and up and down. So there's no, the limit doesn't exist, right? If it's equal to 1, if it's, or higher, it will approach infinity because it will be 2 plus 4 plus 8. The number is only getting bigger. It's not going up and down. However, if there's a negative sign in front of it, then it will be negative 2 plus negative 4 plus negative 8. So it'll approach negative infinity, right? So this is undetermined, doesn't exist, does not exist. And this is infinity or negative infinity. Negative infinity. So let's work it out. You push your youngest cousin on a tire one time, and then allow your cousin to swing freely. On the first swing, your cousin travels a distance of 14 feet. Okay, let's put 14 up here. Right? On each successive swing, your cousin travels 75% of the previous distance. 75 is 3/4. So 1 minus 3/4. What's the total distance? Well, that's just 14 over 1/4, which is 56. 56 feet. Right? And these things actually do happen in real life, right? That, of course, is more complicated with the wind and stuff. But if you swing, you can actually determine how much distance you swung. If you know like how much of the distance the first swing was compared to the second swing. So let's do 26. How do you see it? The graph shows the partial sums of this series, and what's the value of a as n from 1 to infinity. That's another meaning of an infinite series. So it diverges. It looks like it converges to a certain line, and this is what they call an asymptote. I think I already told you that. It's called an asymptote. That means it will never reach that line. But as the number reaches infinity, it'll get closer and closer to that line. So the sum is 1.5. Actually, no, the sum's not 1.5. The sum's not 1.5. The sum is this number right here. Right? The biggest number that you will get out of all out of this series is 1.5, but it's 0.75. Actually, no, it is 1.5. Never mind. I thought these were series sums. These were from sequences, and you have to add all of them. It is 1.5. It's 1.5. Okay, next. Okay, so this is a Sierpinski's triangle. It's a fractal with equilateral triangles, and the process of removing smaller triangles from larger triangles, joining the midpoints of the sides in larger triangles like this. Okay, let A of n be the total area of all the triangles that are removed at stage n. So stage 1, it's 1/4. Right, stage 2, it's 3/16. Right, stage 3, it looks like there's 64, and we have 9 removed, so 9 over 64. So our rule is 4 to the n minus 1 over 3 to the n minus 1. 3 to the n minus 1 over 4 to the n. 4 to the n. Right? Yeah, 3 to the n minus 1 over 4 to the n. Yes, okay. We gotta turn this to the n minus 1 form so we can combine it easier, so we can solve this next question. So this will get us 3 to the n minus 1 is 3 to the n divided by 3. 3 to the n divided by 3 times 4 dn. Actually, no, we'll just do this bit. So find the sum as n approaches n from 1 to infinity of a to the n, and interpret your answer in the context of the situation. So in this thing, every single term, your first term is 1/4, and your second term is okay. I'm gonna put the thing again, 3n minus 1 over 4 to the n. right? Your second term is multiplied by 3 over 4, and your next term multiplies by 3 over 4, and it keeps multiplying by 3 over 4, so it'll actually be 1/4 over 1 minus 3 over 4, which is equal to 1/4 over 1/4, and you know, the same number divided by itself is 1. So at the end of this never-ending sequence, all of the area will be removed. The whole area will be removed. See, as the number approaches infinity, the whole every part of this fractal will be removed. But if you just say infinity, who knows how much is going to be removed at infinity? But as we approach infinity, it seems like it's going to be a 1. The whole thing's going to be removed, and that's it. So that's gonna be it for today's episode. Next time we have trigonometric functions. I'm gonna start on trigonometry, and we're gonna end off the year with statistics and geometry. But that's gonna be it. I should probably start uploading more chemistry videos because I have been kind of slacking on those, more Nihongo as well. But that's all I have for the update, and I'll see you next time with trigonometry.